All right, today we're stepping into the ring for a major showdown in the world of natural language processing. In one corner, you've got the battle-tested champion of production NLP, spaCy, and in the other, the sensational new contender that's taken the world by storm, the large language model.
And this really brings us to the one question on pretty much every developer's mind right now. With the incredible, mind-bending power of LLMs, is a library like spaCy even relevant anymore? Has this new creative genius made the old industrial workhorse obsolete? Okay, let's really get into this. To get this right, you have to see them not as old versus new, but as two fundamentally different philosophies. Think of spaCy as the industrial powerhouse. It's built in Python, which means it's blazing fast, running at near-native speeds. It's designed for production. It's efficient, reliable, and it gives you total control. On the other hand, LLMs are the creative genius. They just operate on a whole different level, you know? They excel at deep contextual understanding, reasoning, and generating text that feels incredibly human.
So let's put them to the test. Round 1 is all about accuracy. How well do they actually do the job? And this is where we see that classic trade-off between pure, raw precision and a deep understanding of context.
You know, a recent research paper just nails this challenge with one simple question. Imagine the sentence, April Blake met Justice Hope. Is Hope a person's name, or is it an abstract idea? To get that right, you can't just look at the word. You have to understand the entire context surrounding it. Now check out this data, because this is fascinating. When it came to figuring out that tricky name, Justice Hope, the LLM, in this case Gemini, scored a near-perfect 0.96. But spaCy, it really struggled, only hitting about 0.47. But now look what happens when you give it something clear and structured, like a date. Here, spaCy is the king. It scores a 0.93, actually edging out the LLM just a tiny bit. So the takeaway from round 1 is crystal clear. For tasks that need deep, nuanced context, like figuring out ambiguous names or even understanding old-timey language in historical texts, LLMs have a huge advantage. But for high-volume, structured data extraction, traditional tools like spaCy are not only competitive, they can actually be more precise.
Okay, so let's move on to round 2, which builds on this idea, efficiency. Because, let's be real, in production applications, amazing accuracy doesn't matter one bit if your service is too slow to use. We're talking about the need for speed.
And this is where the difference just becomes staggering. A comprehensive benchmark on text classification found that, on average, fine-tuning and running LLMs was 590 times slower. Let me say that again, not 5 times, 590 times slower than traditional methods.
And believe it or not, it can get even more extreme. Another study, this one looking at processing historical texts, found that for some tasks, the actual wall clock time for an LLM was up to 2,300 times longer than a regular NLP pipeline. Just wow.
Let's be really clear about what a number like that means. This isn't just some abstract figure on a chart. For any app that has to process tons of text with almost no delay, this is literally the difference between a product that ships and a product that fails because it just can't keep up. Which brings us to our third and final round, the true cost. Because today, efficiency isn't just about speed and compute cycles anymore. It's also about the financial and, yes, the environmental impact.
Just think about this for a second. According to one study, the process of fine-tuning a single large language model can generate an estimated 170 kilograms of carbon dioxide equivalent.
And this chart just illustrates the scale of the difference so well. The carbon footprint for fine-tuning traditional models, it's tiny in comparison, right? Around 6.5 kilograms. For LLMs, it's orders of magnitude higher. That is a cost that we really can't ignore. So, after 3 rounds looking at accuracy, speed, and cost, what's the verdict? How in the world do you choose your champion for your next NLP project? Well, the answer is there is no single knockout winner. This isn't a simple case of new tech just replacing the old. The right choice depends entirely, 100%, on the specific job you need to get done. So here's a pretty practical guide based on everything we've seen. If your app demands raw speed, tight control, and cost efficiency for well-defined tasks at a massive scale, spaCy is absolutely your champion, no question.
If you need that state-of-the-art context for tricky, ambiguous text, and you can afford to take the hit on speed and cost, then an LLM is the tool for you. But what about that sweet spot right in the middle? Well, a lot of research points to small language models. Think of models like Roberta. They're way more compact and efficient than the giant LLMs, but they're still packed with enough power to offer a nearly perfect balance of performance and cost.
But what if this whole versus debate is just the wrong way to look at it? Maybe the future of production NLP isn't about choosing one over the other. Maybe it's an alliance, a hybrid approach that gives you the best of both worlds.
I mean, what if you could combine the industrial strength, speed, and structure of spaCy with the creative genius and reasoning of an LLM, all inside a single pipeline?
Well, that is exactly what spaCy-llm does. It's a library from the same people who make spaCy, and it basically acts as a bridge, letting you plug an LLM directly into a familiar, robust spaCy pipeline.
And here's how it works, and it's so smart. First, use spaCy's lightning-fast components for all the heavy lifting, right? The tokenization, sentence splitting, extracting all the easy structured stuff. Second, for only the most complex parts of the text, the bits that require that deep reasoning, you make a strategic, targeted call out to an LLM. And finally, this is the key. You use spaCy's powerful tools to take the potentially messy, unstructured output from the LLM and parse it into reliable, structured data you can actually use in your app. It's brilliant.
This really leaves us with a final crucial question. Maybe the future of AI isn't just a race to build bigger and bigger and bigger models. Maybe it's about building smarter, more efficient stacks that use the right tool for the right job at exactly the right time.